Yeah. So, interest. Simple interest versus compound interest. I need you to pay attention to this for a second. Let's say for some odd reason, somebody in here loans me $1,000. Chris, you loaned me $1,000. So, simple interest would be this. All right. Here's the transaction. Chris gives me the $1,000. He says, "All right, you've got to pay this back to me, obviously, but I'm going to charge you 10% interest." So, how much would I owe Chris in that case? 20%? You're a crook. All right, I'm going to borrow from somebody else. But anyway, if he's charging me 10% interest, you guys, this is simple math, Brett. How much would I owe him back?
How about I just loan you it so that no interest has to be paid?
There's got to be interest. What's 10% of 1,000, you guys?
100.
So then I would owe him the $1,000 plus the interest, which is $100. So I would owe him $1,100. Right? That's simple interest. Now here's another transaction. Okay? Let's say Christian, he's a little bit sharper. He knows about this interest. He says, "All right, I'll loan you the $1,000, but you have a time frame to pay it back. You've got 6 months to pay it back. Each month you don't pay it back, I'm going to charge you 10% interest per month." Let's say I can't pay him back until the 6th month is over. Listen carefully. After month 1, what's the new balance of the loan? It was originally $1,000, but after month 1, it's $1,100. Okay. Now the next month, you guys, this is where we need to be careful with. Do you guys need new seats?
He does.
Yes.
After month 1, it was $1,100, but after month 2, it's another 10%. But 10% of what now? 10% of $1,100. So the interest is even more. Okay. Now after month 3, that's going to be 10% of the growing total. Do you see how that can grow and get bigger and bigger pretty quickly?
Yeah.
That's compound interest. Compound interest is interest that's applied regularly over a set amount of time. You end up accruing much more interest that way.
Oh, that's disgusting.
40%? You guys sound like a real bank. Now, you guys have, I assume, taken financial literacy? Did you go over how credit cards work? Did they tell you how high the APR is on your credit card balance? It's like 30% on average for most credit cards. Just saying. Credit cards, they're good to have to establish your credit line, but you don't want to have a standing balance on your credit card because it just keeps accruing a ton of interest. Anywho, here's the formula. A nice little formula there. That's the formula. You're going to want to write this down because I doubt you can just glance at this a couple of times and have it memorized and then use that on your assignment. You might want to write this down.
On our stage testing, we're going to have like one of those.
Did we not do this?
Holy cow! I am happy.
This, I'm glad you're happy. This is 1 plus r. This is an r divided by n.
What's an N?
This is an n down here. And this is an exponent of n times t. Now you need to write down what all these letters mean. A is the future amount. After a certain amount of time has passed, that's what the future amount is going to be. For amount, A for amount.
But F for future.
So, okay, is secondary math harder?
About S.
In some ways.
So that means the R math is harder.
In some ways. Secondary math 2 is like algebra 2 combined with geometry.
So our class, okay, so their class is easier.
No, I would. Anywho,
Wait, so we have to do, you have to take it then?
we're going to take an AccuPlacer test at the end of the year.
Okay.
it doesn't go on your grade, but it just tells you whether or not you can take 1010 or 1050. R stands for the interest rate. Oh, we skipped P. P is the principal amount. Does anybody know what the principal amount even means? The beginning amount. If you invest $10,000, then what's the principal? $10,000. Or if you borrow $10,000, then that's the principal amount. R is the interest rate. T is time, and in this formula it's measured in years. Because usually when you make an investment, you invest for a long period of time. This is one where you need to listen carefully. This value right here, N. Make sure you write that down exactly as it's written. Exactly. Exactly. Very good. It's the number of times per year that the interest compounds. So on your worksheet, you will see words like Sam was mentioning, annually. If it says that your interest is going to compound annually, then how many times per year is that? 1. So N would equal 1. If it uses the word semi-annually, how many times per year is that? Twice. So then N would equal 2. If it uses the word monthly, then N would be 12, and so on and so on. So that's what N means. Right? So you guys, all you're going to have to do on these problems, I'm going to give you the time in years, I'm going to give you the interest rate, I'm even going to give you the principal amount and the number of times it compounds. All you got to do is plug everything into the formula to figure out the future amount. It's pretty easy. Just got to be careful on how you plug this in and make sure things are in the right order of operations. So here's an example. I don't sound like that. Yeah, write this down. Let's write this down. Suppose you invest $5,000. I don't know where you got it from. Let's say your dear old grandma died and left you an inheritance of $5,000. And like a responsible teenager, rather than spending it on a new Xbox and a big screen TV for your room, which is the stupidest thing you could do, you invest it wisely into a mutual fund or a bond or something that's safe and secure.
Are you serious? Yeah, dude, I've lost $2,000.
That's how the Wolf of Wall Street. God.
Well, that's a movie.
No, it isn't. He lied. That's how he got successful.
What was that movie about?
So you invest it into an account that yields 7%. That's rather high. Usually it's not that high, but we'll just say you got a great deal and it's going to be 7%. And it's compounded semi-annually. So, here's the question. How much will you have after 10 years? Now, you need to understand something about this problem. This makes a lot of unwritten assumptions. Number one assumption, this problem assumes that you make no more future deposits. You make the initial principal deposit and then you just leave it alone. Okay. The second thing that it assumes is that the interest rate stays the same for the duration of the 10 years, which in the stock market doesn't happen, but if you put it in like a CD or something where it just stays in there, then it might have the same interest. So that's a lot of assumptions here. But assuming you don't make any more deposits and assuming that 7% interest rate stays the same, how much will you have after 10 years? So let's decide on the values. What's the principal investment? $5,000, okay. I want you to think for 5 seconds before you blurt out an answer. Please think for 5 seconds. What's the interest? Or what is the value of the interest that we're going to plug into the formula? Think silently for a second. Really think about what the word percent means. The value of R is 0.07, you guys. Did everybody hear that? That's one of the most common mistakes I see students make. 7% is not a number you can use in a formula. It's 0.07. Because the word percent means of 100. What's 7 of 100? 0.07. That's the number that you use. 0.07. How many years? That's an easy one. Why am I asking so many easy questions? T equals 10. Ooh, here's a tough one. What's the value of n? 2. N equals 2. So these are all the values you need. All you got to do is plug them into the formula.
Easy.
So here's what the formula looks like when you plug it in. N, because it's semi-annually. Now, where'd the 20 right here come from? 2 times 10, exactly. All right, so here's where you have to decide your own level of comfort with your calculator. Some students can successfully type this all in at once and hit enter. But not very many students can do that. Most of you are probably going to have to break this down into smaller chunks. Here's what I mean. Here's what I would do. Assuming I'm not super comfortable with the calculator, I would do this fraction right here first. 0.07 divided by 2. 0.07 divided by 2. Hit enter. What actually comes next in order of operations? I'd have to add 1, so I'm going to, on my calculator, hit plus 1. That puts it to 1.035. What's the next thing I would do in order of operations? I heard 2 different things there. Do you raise it to the 20th power or do you multiply by 5,000? Exponents come first before multiplying, so we're going to have to raise it to the 20th power. So I'm going to take this and raise it to the 20th power. Now before I hit enter, I want you guys to understand a little bit of number theory here. Raising something to the 20th power, doesn't that usually make a giant number? But take a look at what we're raising, 1.035. That's essentially the number 1, right? If you take 1 and raise it to the 20th power, what do you get? 1. So are we expecting a super huge number out of this? Not really. 1.989, not a real big number. Now what do we do? Now you multiply by 5,000. Did anybody have an estimate on how much they thought this would be? That's your estimate? You're reading that off your calculator?
Yeah! I put it all in at once.
Did you? $9,948? 94 cents. Now, you guys, you need to understand this. Is this the interest that you earned, or is this the future amount? This is the future amount. So what was the actual interest that you earned? $4,948.
That is insane.
Wait.
This is the future amount. So $5,000 became $9,948.
Basically, over 10 years, you earned your money.
4,000.
That's why it's so wise to make good investments. Because you basically get money for not doing anything.
But then what does interest become after that?
If you left it in there for longer. Yeah. So the answer is $9,948.94. All right. I want you to think to yourself, you guys, listen to this. What effect would this have had if I changed the word semi-annually to monthly? What effect would that have had? It wouldn't have been raised to the 20th power. It would have been raised, because n would be 12 in that case, right? If I'm doing this monthly, and then 10 times 12 would be 120. I want you to think for just a second. Obviously, that's going to make more money, right?
Yep.
How much more money do you think? If I raise it to the 120th power rather than the 20th power? Let's actually do that. Let's do part B here. What if it's compounded monthly? We would assume that this is going to be Pretty big increase, right? Because instead of compounding twice per year, this is compounding 12 times per year. That's got to be, what, $1 billion? What are we thinking? Maybe 100,000? Tens of thousands? It's okay. Here's what the formula would look like, right? You plug everything in that you know. You plug in. Now, you guys, you got to be careful. Not just the exponent has changed. Look carefully at this formula. What else has changed? We're dividing by 12 rather than dividing by 2. I want you guys to actually follow along with me for just a second, because this answer might surprise you slightly. It might surprise you. Here's why. You guys, take a look. The first part of this is 0.07 divided by 12. 0.07 divided by 12. That's 0.0058. Now you add 1 to that. And it's 1.0058. Now, I want you guys to really try hard to understand this. Yes, you are right that this exponent is much larger than this exponent. But this really doesn't matter. Why? It's because the base has gotten a lot smaller. Here the base is 1.005, and we're taking that to the 120th power. Do you remember what the base was before that we rose to the 20th power? It was 1.03. That was a little bit of a larger base. Do you see why this might not make as big a difference as you think? The base gets smaller and the exponent increases, so it really kind of evens out. So anyway, we have to raise this to the 120th power. Then we multiply that by 5,000. And it's $10,048. So just a little bit more. It's $100 more. So it's not really how often it compounds that makes a big difference. What could I have changed on this formula to make a huge difference? The interest rate is the most important thing. Even if it's to 8% or 9%, that would have made a huge difference. Or what else would have made a difference? What if I left it in there for 50 years? So the amount of time you leave it in there makes a big difference. But how often it compounds doesn't really matter. I mean, you're going to make a little more money, but not a substantial amount of money. Okay, here's another thing I want you to think about. Just answer as quick as you can. What if I said it was going to compound daily? Then what's n? 365, right? That would have made a little more money, but knowing what we know now, would that have made a huge difference? Not a huge difference. What if it compounded every hour? Then you would do 365 times 24. Because there's 24 hours in a day. That'd be a pretty big exponent, right? What if it was compounded every minute? Or every second? Or every half second? Okay? What I'm getting at, you guys, is as the number of times it compounds reaches infinity, there's a new type of interest called continuously compounding interest. This has a new formula. This is interest that is always compounding on itself at every moment of time, every day of the year. Even Christmas, it never even takes a holiday. Continuously compounding interest. This is where n has gotten so large, where it's not just compounding every second or every half second, it's compounding all the time. Before I show you the formula, though, I need to introduce you to somebody. Actually, it's a new number. You guys thought you knew all the numbers, didn't you? There's a new number. More numbers. The number E.
Letter.
No, it's a number. Sesame Street lied to you. E is not a letter. It's a number. E has to be raised to a power, yeah. E is a base and it's raised to a power. You guys, E is just a symbol that stands for a number. If I wrote this symbol on the screen, you would all immediately recognize this symbol and be able to tell me its value, right? What would you say? That's pi, right? What's the value of pi? If I wrote this on the screen, I think some of you in here would still recognize this. What's the value of I? Close. Square root of -1. I is just a symbol that stands for a number. Same thing with E. E is just a symbol. It stands for a number. It's an irrational number. Here's the, it's about 2.71. What the crap happened there? Is that somebody in here?
That's what it said.
What did it say?
Said I'm gay.
Yeah, teenagers are awesome. E is called the natural number. And its approximate value is 2.71. I don't know. What's that? Probably. It's called the natural number because this value 2.71 occurs quite frequently in naturally occurring phenomenon like population growth, population decay, radioactive decay. It's approximate, yeah, because it doesn't equal 2.71. I'm rounding it here. It's an irrational number. The decimals go on and on and on. So it has to be the wavy lines. All of your calculators should have an E button. If you don't know where it is, you have to find it.
It's right here.
On my calculator, it's right above the LN button. I don't know where it is on all of yours, but you do need to find it. Otherwise, you can't do the assignment today.
Wait, is it uppercase E or lowercase?
Lowercase. Here's how it works on mine. I have to press the second button and then the LN, and it gives me that little E that I can then raise to a power. On this one,
would it be that E, or would it be this E?
It's that one right there. Yep, it's that one right there. So if you're wondering where it is on yours, I could probably help you find it here in a second. But anyway, here's the formula for continuously compounding interest. Most students just try to remember the acronym PERT. PERT, principal. P still stands for principal. E is that natural number. R is rate. T is time. Notice we don't have N anymore. Where the heck did N go? We don't need N because it's always compounding at every moment of time. N has approached infinity. Yeah, it's irrational, yeah. It is, it's just more advanced, so you don't learn about it until you get to more advanced math classes. Like this one. But in college level mathematics, E is every bit as useful as pi. Anyway, let's do the same problem from example 1, but let's do it with continuously compounding interest rather than just regular compounding interest. Let's see what happens. So use the formula. The future amount A E is what's being raised to that power. So E is being raised to the 0.07 times 10. You probably can type this all in at once on your calculator rather than breaking it down, if you're careful. Ooh, here we go. I wasn't being careful. There we go. 5,000. Now type in the little E button wherever it is on your calculator. You got to find it. Now make sure that the rest of this is an exponent. 0.07 times 10. And then hit enter. $10,068. So it's not much more than compounding monthly. Type that. And parentheses. 0.7 times 67.
I got that number.
Oh, because you have to multiply it by 10, the 0.07.
It's there. It's just, I don't know if you can skip over to see it.
Oh, if you close the parenthesis, that means that's no longer part of the exponent.
Okay.
So you want to make sure that times 10 and then close the parenthesis.
Oh,
There you
okay.
go.
Okay.
So, yeah, you're going to have a calculator with you for doing this assignment at all times, and you're going to have to know how to use your calculator. But that's pretty much it. Yeah, round it to the nearest hundredth.